if anybody is not if anybody is not familiar with Baltimore, it is a city that was built, on the coast, in really to support shipping industry, historically, very much like many of the major cities along the East Coast. The National Aquarium itself, you can see in the circle diagram, has two piers that they have their two facilities on. They call it Pier 3 Pavilion and the Pier 4 Pavilion. And the project that we're talking about is located in the slip of water between the two pavilions. So it is really at in the Inner Harbor, which is sort of the beginning of the Patapsco River. It leads out into the Chesapeake Bay watershed. And, the National Aquarium, one of their mission items, it is to preserve and habitats for aquatic animals. They go out in the field and they do this, all across our state. They do this, even regionally and in some cases nationally. But their site for their building was in an extremely compromised location in Baltimore City. And this is what was right outside of their door, in the slip between the waters. It's almost hard to look at this image when I see it. That is not trash in the water that you're seeing. That is a fish kill. Those are dead fish that are floating in the water. This is something that still will happen to Baltimore's water intermittently. Whenever there's a depletion of oxygen, it actually comes from significant, very quick temperature changes. It happens annually, more in the fall time, because it gets really cold at night and it gets really hot in the day, and it causes the water column to totally flip, which brings all of the sediment that is on the bottom of the harbor, where these things kind of live in darkness, up to the top of the water, and they multiply and they take the oxygen out of the water itself. As a result, the fish don't have any, there's no oxygen for them to be able to get into their system, and sadly, there are fish kills. So they did not want that at the forefront of their doorstep. And this project was a way to really showcase their mission and showcase the work that they were doing elsewhere, right in this urban environment, at their footsteps. And this chart is so simple, and it will probably not surprise any of us in this room that before the Western development in Baltimore, the ecological health of the city was very high. It was a natural salt marsh in this location. But as humans came and developed the Industrial Revolution, the edge of that landscape and that transition between the water and the land changed very fast. So at the end of the chart, when the human impact was high, that is really whenever the natural ecological health of our harbor was at its worst. And one of the ways that is kind of interesting to look at is, although this still has development, but this is a historic map from 1792 of Baltimore. And the area that is blue obviously is where the water was, and where the Jones Falls kind of comes down. That's that stream, and where it meets the headwaters of the Patapsco River that again leads into the Chesapeake Bay. And the dark blue here is how much the city has built into the water. So all of the natural edges, some of which even in the historic map are not there. You can see where kind of there are piers and edges. But the city built out into the harbor. And for the majority of those, the new condition where kind of the water meets the land, it's not a living shoreline. It is a hard bulkhead edge. So it is, it's really our promenade. And then there's a built edge and water. There is no natural material between the two, and which sort of exacerbates all of these problems. So there are no natural sort of filters or way to accommodate that. And our task on this project was really to take what at the time was kind of the existing condition. You didn't see fish unless they were, this is, I mean, really sad to say, unless they were kind of like the dead ones on top. You never saw water, you very seldom saw like waterfowl, anything else, but it was to create an environment that would allow these aquatic animals to survive and to thrive. And it will probably not surprise you to learn that this was not, woke up one day and said, oh, we're going to make a floating wetland. And then 2 years later, it was installed. This was really an act of, a very intentional act that the National Aquarium had been doing well before Ayers Saint Gross went in to work with them. So the National Aquarium started doing floating wetland prototypes in 2011. They did multiple floating wetlands that would be great for like 2 years, 3 years, and then they would sink. And then they would replace them. And so this was really a continuation of that, and also kind of weaving it into their campus-wide planning of how to really interpret what their mission was on site that led to this project. They pulled us in to work with them in, if I'm following my lines here, for the waterfront campus plan in 2015, where we looked at the whole campus, and the floating wetland was one component of that. But then the very interesting thing was that they started this prototype with a small, tiny, portion of the wetland back in it actually was like 2017 installed, and then they got their first year of data in 2018 to show if it was successful and if it was meeting their goals and criteria. Then they went to fundraise, and the world, went into shutdown, and COVID happened and everything. So there was a longer prototype than maybe we all had, it had originally thought. But in 2022, they were able to reach their fundraising goals and build the full floating wetland. And it just opened not this past August, but the August prior. So it has been installed, and it has seen annual sort of, seasonal changes, and continues to be studied, and having sort of post-occupancy, both of social and ecological values. This is just sort of a visual graphic that shows you the timeline and the spanning of whenever all the different prototypes that they had installed. So you can see that there are like 1, 2, 3, 4, there are 5 versions of floating wetlands that they installed that just, they made an investment and they were gone within, 2 or 3 years. And it wasn't until that third from the right circle, it's the second from the right circle, that's the prototype that is still there today, and they're able to maintain it, that led to this. It's hard to talk about this project and the health of Baltimore's Inner Harbor without really acknowledging that there were many other things that were helping to support the health of the water in the harbor. The Healthy Harbor Initiative, which a local nonprofit waterfront partnership led, also started whenever that first wetlands went in. Many measures have been taken that ultimately led to, conveniently, between when our prototype and wetland went in, so it was a very good timing for understanding this project, that the harbor had its first annual swim back in 2024. So that was a very big deal for the city of Baltimore. And it was a big deal for this project too, because people are starting to see the harbor as not something that you have to, stay away from, but something that you can connect to and touch. So the waterfront campus plan, as I said, is how whenever the aquarium first engaged Ayers Saint Gross, and they asked us to look at their 2 piers, Piers 3 and Piers 4, very exciting names. The piers are all numbered in Baltimore, by the way, and their facilities. What they wanted to do was to interpret all of the ecosystems of the Chesapeake Bay watershed, which is obviously our watershed, on their site. And so we worked with them to identify the different areas to interpret the different types of ecologies on their site. they already had the Highland Forest partially installed, which is right at their front door. And then we evaluated with them, all these different options, and we actually took to SD's design for all of those different habitats. But what really rose to the top whole project with their fundraising and within their institution was the interest in transitioning this slip between their Piers 3 and Piers 4 into the salt marsh habitat with the floating wetland. And so the project itself, when you look at the details, has a different form and looks very different in some ways from this when you look at the details, but essentially it is the same. It is a way that you could have a long-term floating wetland that would have longevity and have all the ecological functions that they wanted, with a floating dock that allows people to go down, connect to nature, and really understand the systems that are at play at the aquarium. And whenever we originally did this work for them, they made a commitment that the floating wetland would be free of charge. So to go to any museum, the National Aquarium included, it is an expensive experience. But the National Aquarium has made the commitment to have the floating wetland open to the public. So it has become part of the public realm and during the operating hours for the National Aquarium. And even at the onset, we were talking about, well, what happens whenever it's not open? People are still going to want to experience it. So we worked with some of the existing infrastructure. This is an existing suspension bridge, and really thought about, well, you can also still experience it from the promenades on the edge and from the bridge itself there. And as I indicated in the timeline, the first thing that happened in I think it was installed mid-2017 with the first year of research. In 2018 was the floating wetland prototype. And it is impossible for, I think, Jason and I to sit here and to talk about this project and not talk about the people that we worked with at the National Aquarium. Because many of us, probably maybe all of us in this room, are landscape architects. And it is not like we woke up one day and said, we want to design a floating wetland for the National Aquarium that meets these criteria. It really was the vision of the people who are working with the aquatic animals day in and day out that was integral into this solution. And learning from those 10 years or 7 years that they had installed all of those wetlands prior to our arrival, why they failed and what were the problems that we needed to overcome. And I think that, I'd like to say, somebody once asked me, they're like, what was it like, designing this for the National Aquarium? And I do think the right way of saying that statement is, we designed this with the National Aquarium. So we were able to find a way to design and make their vision a reality. And so these are two very important people, Jack and Charmaine. They still, if you go there, you are very likely to run into one of them. They're pretty much there almost every day at some point. Jason was just there for a photo.
Yeah, I just kind of, Jack, who's in here, Jack Cover, he since retired, since the completion of the project, and he's out there about 3 times a day, 3 times a week, I should say. So as much as this was his kind of, the genesis came from him, and you'll see later on in some of the slides what we mean by that. It is a love of life for them. He has not passed it on. He has such an appreciation for this project, and it was his baby basically for his entire time. He's had this as a vision for him for that entire time. And so even though he's retired, you'll still find him out there.
Yes. And yeah, we've met his son because he brings his family there. It's pretty nice. So this is a very interesting detail that Jack made. We would go to meetings. This is how involved he was with the design. We would go to meetings and we would never know what Jack would show up with. We started calling his 11 by 17 sections, he had little fish that he would rub, and transfer them on. And they were just so sweet because essentially he was saying to us ideas, and then he would go and draw them up. And it was like the most interactive client I think I've ever worked with. We had a name. We used to call these like, they weren't drawing sets. They were 11 by 17. So we would call them, like, Jack would bring another packet. So we'd be like, there's another jacket on the table. There was one time where and this was actually a critical moment in this project, where Jack brought kind of the knowledge of how you keep aquatic animals alive inside, which is through aeration, and the idea of bringing that to the exterior, which is how the fish are actually surviving when there are fish kills in Baltimore Harbor. And we showed up, and in the middle of the conference room table was a giant aquarium with he made like a little tiny, I mean, it was like probably this big wetland, and he had hooked up like an aquarium aeration system to it. And from that, we worked in that meeting and figured out how it would both kind of go down and filter the water from below, but also how it would flow the water and aerate the water through the channel in the floating wetland itself. So, and
just kind of as context too, the aquarium, if you've been to any aquarium, I mean, they also exhibit design, components to it, right? A lot of that's also kept in house. Same with them, and so they're used to kind of being hands-on. And part of that story there is that aquarium, he took a piece of styrofoam and basically, X-Actos and whatever, and worked out a small little formation of a wetland that he had in his mind after the sketch, and actually formed the channel that he thought it would be, and hooked up these different little pieces of an aquarium to provide what aeration would look like. What is the channel flow? How would that possibly happen? And so again, they're very hands-on, and we found that out. Again, that's where I'll be speaking a little bit later, the construction aspects, how they prototyped a lot of things that we had drawn up, or they had drawn up in-house. I mean, they have a very large 3D printer. It's, for those that like it, you really geek out. But that was pretty cool. They some of the fittings, some of the other pieces and parts that are part of the aeration system that we had installed, they actually fabricated over 300 of them to put it in and install. So again, it wasn't just us coming up one day and like, hey guys, this is what we're going to do. No, it was a collaborative effort, very much back and forth, a lot of learning on our part to understand what they need and what is expected. And then us kind of molding that vision into a practical aspect of like, well, here's our other folks that are with us, the CM, the engineers, this is how we can make that work. So it was a very, collaborative effort throughout.
Yes. But what did, we know each other very well right now. We had good days and we had bad days, but we all still really like each other. So that was a sign of success, we think. So the three things that they really wanted that make this wetland different than other floating wetlands are that it was built to have long-term buoyancy. A traditional floating wetland in the brackish water where we live in Baltimore has great biomass growth to it. And over time, like all of the stuff that is growing underwater that you can't see gets so heavy that it can't be supported by the initial inflatable sort of elements of the floating wetland. And that's why they were sinking. And they were trying different systems, but they realized that they were never going to be able to overcome that without having some sort of like very significant way to change buoyancy. And Jason will go into more details with that, but so we used a pontoon system that they could adjust the buoyancy. The second thing was, as I mentioned earlier, the addition of aeration. So again, it's what they knew from the interior, keeping aquatic life alive inside in their aquariums, and bringing that to the outside. And the aeration is adjustable, and it does not always have to be running, but it almost always is, because it actually helps with sort of the water flow in the direction that we want it to. But they can also pump it up if they need to pump it up. And that allows the area at the wetland, immediately adjacent to the wetland, to act as a refuge for aquatic life if there is a fish kill. And they have seen that a lot of the animals will kind of come to the surface during those environments in that condition, because they need to be closer to where the oxygen is. So that has been successful. And then the third thing was expanded habitat, which the other original floating wetlands did have. This was just a more precise habitat that looked at being able to really control sort of the high marsh and the low marsh conditions, which again, Jason will talk through all the details on the technical aspects of those three things, but those were the primary kind of goals of what they wanted us to focus on that made this different than everything that kind of existed prior. And so for many of our projects, and we start out developing principles with a client that really act as sort of like, the foundations for the project moving forward. And it is an evaluation tool that allows you sometimes when you're making VE decisions to decide, okay, we are going to do this because it hits one of our main goals, or to just, to not do something because it doesn't, support one of those goals. And from the onset, and this is also a practice that the National Aquarium, as Jason said, they are exhibit designers. They do their own interior exhibits. And so they always have their own sort of goal statements. So that was very good that we kind of both came from that background. The two major goals are to promote urban conservation, but also to be a social space and a civic anchor. And that little quote there on the bottom is from a very early sort of visitor post-occupancy evaluation that they did, that it was somebody saying that, I live here. When I come, I just walk past the water, but I don't engage with it. And now that this is here, it's a reason for me to actually stop and to engage with the water. So that was an early good sign. And one of the things that thanks. So because it's kind of boring just listening to Jason and I talk the whole time. So and the National Aquarium themselves put together during construction a short video that talks about some of their aspirations for this project and in their own words. So we're going to go through this so that you can hear, from them what their vision was for the project.
I'm excited for people to not make a gross face when you talk about what lives in the harbor.
Right now, the Harbor Wetland is still undergoing construction.
There's a lot of
it's also good because it lets you see it under construction
working going on.
They've already laid down PET, and that will allow us to go in there and start planting those 33,000 grasses.
This harbor wetland is going to be an oasis sort of in the middle of the concrete harbor that we've built for humans, and it's sort of a landing pad for the animals that we've pushed out of their home.
This will be a huge uptake in wetland plants and that ecosystem, which is desperately needed. That's why people have a negative view of the harbor, is because it's missing its kind of caretaker, and now we get to put that caretaker back in the water.
My exciting part is having people realizing how many animals call the inner harbor home.
I want to see birds, ducks and geese.
People will be able to go out there and see, diamondback terrapins, herons. They'll see oysters and blue crabs and fish and turtles in the water.
I'm a big bird nerd, and I love me some wetland birds anyway, and I can't wait to have some kid on the bridge be like, oh my god, look at the heron, I've never seen one of those before.
This wetland is really more than just something to look at. It definitely plays back into the people who live here.
I'm also excited just for people to have a park and be able to bring their family or friends out and actually stand on the water and learn more about different ecosystems that are right here in Baltimore and what it looked like hundreds of years ago.
I like that the aquarium wants to inspire people and draw them in, and I think this will really draw people in and get them considering the harbor as more than just a tourist area, but really as a pivotal part of our city. I'm excited for people to...
Won't make you watch it twice. So so that's what we did. We tried to, you know, answer those challenges that they had, and you can see some of the initial sketches that look renderings that look very much like what you saw being installed there, and this is what is there today. And you can see, I think this is a really nice photograph because it lets you see kind of the scale of it as it relates to those two pavilions on either side and the relationship with that suspension bridge. It's also kind of a good juxtaposition between, do you see those two float here? These are two restaurant floating docks right here that are actually a reason that in the state of Maryland, you are not allowed to build anything that covers the water, because then there is a loss of habitat underneath it where there's no sun that gets in, and it is a result of like things like that. And so that is like, those are grandfathered in and exist. And just on the other side of the bridge is a project that we had to get special permission because it essentially does block and create like some water that doesn't get sunlight. But Maryland Department of Engineer and the Army Corps of Engineer, Maryland Department of the Environment and the Army Corps of Engineer thought that the ecological benefits greatly outweighed any negative ones, so they approved this particular project. And like today, I think it's like pretty exciting because it has become a social space and a civic anchor. You know, I have a friend who runs the Inner Harbor every morning, and she runs from like, you know, her house in Federal Hill over, and then this is like the loop. She goes on the floating dock and goes back. It's great. She sends me photographs of animals and things she sees there. But you also go there and you see kids pulling their parents when they're walking down the promenade, like pulling them, come on, I want to go down there. And so that has been like, you know, satisfying for us to see, but also check that we got the one goal. And from the National Aquarium has actively staffs this. So they have programs, they have where they bring high school students and they bring them down to the wetland itself. They go out, they collect information, they work with the students, and they actually sort through and look at it. So they are promoting this conservation, education, you know, on the dock itself. So that's been, you know, satisfying to see as well. And we're gonna shift the computer here for everybody online.
That's good.
And let Jason walk through some of the details there.
Thank you. So again, as we showed this previously, just kind of walk through some of the technical aspects, some of the construction aspects that went into, obviously, we now know the vision, we now know some of the things that went into play, what we're trying to address and trying to accomplish aspirationally and also technically. And so again, this was the prototypes concept, if you will, and that's what got developed in 17, built, and had been out there for a number of years, and kind of set the precedent for what we're going to do. And so with that, as Amelle had alluded to, it is a pontoon system is what they came up with, because the previous ones and what you usually see in most other floating wetlands, as I've kind of termed them, they're set them and forget them. You are able to create something and put something out there that does a job, but because of the biofouling and because of some of just the technical and functional aspects of the environment that they're in and what they're based on, they are going to fail over time. And that was the challenge that they were trying to accomplish with this project, is how can we do better than that? Can we get a time horizon that's 10, 15, 20, 30 years out or longer? And through the process and through this project, we think that, and they think that they do have something that can do that for them. And so part of that is the pontoon system that we described. It allows for aeration to go into the pontoons to allow that to be floated at a certain level in the water. And then they can, you know, move that as they need to. If there is a need for too much water and the plants are dying, they can bring it up. If they need to submerge it, they can do that. If they need to maintain that, they can bring it up. So through that is what the pontoon system works as from that perspective. But then also they want to be able to build the habitat. Well, how do we do that? So that's what was used for that system in the prototype previous, and then now is a system of PET, basically just recycled plastic. if you actually were to hold it, if we had a sample, we brought one, it's actually very dense, very hard and coarse, but it's 96% air. It's very open because of the fibrous nature of how it's put together. And so using that allowed us to build up kind of the strata and kind of the framework for the different profiles needed for the vegetation. There are 2 different types of grasses and 2 different types of shrubs / trees that have been utilized in the system for the habitat. And each one needs a certain amount of water or lack of water. And so allowing us to build the strata through this PET, we could set forms. And so in the CD documentation, if you're going to see it, it's almost like, it's basically a large, Excel schedule. It is, 1A, 1B, it's almost like a Tetris piece of all these different pieces and parts that make up kind of what you see in the left-hand side of the PET pieces together and the reserve buoyancy. And so and to talk about the reserve buoyancy, resiliency, buoyancy, is that the aeration system and the pontoon system allow it to float. But if it ever gets inundated, it needs to come back up. That's what reserve buoyancy is. That's basically, generally speaking, as a human, if you want to think about it for yourself, you go in the water, you're going to float, generally speaking. But if you get inundated or have your clothes on, you get to go down, what's going to bring you back up? Reserve buoyancy is your life preserver. So what's the life preserver for this? That's what you can see with those kind of linear pieces. That's a very, rigid system of another plastic, but it has buoyancy. So basically, as you push down on the system, should it ever done that, it brings it back up. So it's 2 different mechanisms in pieces that allow it to float and to avoid, flooding.
And the pontoon system, it works like a pontoon boat. I mean, it looks like the pontoons on the bottom of the pontoon boats. And the idea is that as the biomass gets heavier, you bleed out the water and you get more air into it to counteract that.
The other benefit is the way the system is, there's a pontoon system, there's a fiber grate layer, which is basically just an open grate kind of system that allows for us to have kind of a stable base. And then the PET was put on top of that. But because it's all open basically throughout the system, besides the pontoon being the biggest structure, if they should ever need to, they could easily go like with a boat, they can go underneath and they can scrape stuff off. So they can do manual cleaning. So again, trying to work past the biofouling aspect is a benefit, as is the aeration. The aeration is allowing stuff that would accumulate, and because you have stagnant waters, static water column, the aeration moves that. Only things that are really going to, like the mollusks are going to get on there, snails, the other things that are actually going to adhere. And yes, you're going to get some biofouling, but it's going to be less so with an aerated system versus if you did not have some sort of movement and agitation. And speaking of that kind of the aeration agitation, there is, as we'll see some of the photos and some of the videos, there is an open channel that's through there. And again, that's part of, again, thinking about the salt marsh systems. Usually you think about that, you see kind of like these little runnels through all of the grasses. That's what they're trying to replicate, because they want tortoises, they want, shellfish, other types of things that need these small little nooks and crannies to happen. For them to happen, they need that to be in the system. So that's what they had, and that goes back to the comment earlier of prototyping, the aeration system that allows for the water column to be pushed and brought through the channel. They fabricated all of the fittings that made that collar system adhere to the fiber grate system and to the overall pontoon system put together. That's the 300 things they printed for us. They fabricated those things. And these are the things where the collars were basically about, 16 inches in diameter and about 8 inches high. And there are different configurations as needed. And they did all that in-house. So that's, again, kind of that collaborative aspect that we had in the project, that it wasn't just us kind of just going and figuring everything out. And so all these things that are coming together, you can see here in the picture, you look on the edges, the little white splashes. That is where aeration is occurring on the edges. As well as what, that's when they're first testing it. You can see all the system out there. They're starting to put the grasses in, all the PET and reserve buoyancy is in, and then you can see the grate. This is all above water. This is when they first went together so they could fabricate it, bring it on site. So fabricated off-site in South Carolina, shipped it up here, put some more component pieces at a marina shop that we had, and then they floated it over. And then we all hooked these rafts, as they call them, the pontoon pieces. There's about 108 rafts that make up this whole system. And then they're all connected on the edges, and then aeration off the edges as well. And again, the aeration that is happening on the edges is doing two things. One, providing water agitation and oxygenation for the wildlife, but at the same time, it is acting as kind of a barrier. With the harbor, tends to have a lot of trash in it. It acts as because the water actually keeps it out to the edges, and that makes it easier for them to maintain it.
Each one of these rectangles, each layer, those are the rafts that were made in South Carolina, shipped abroad, and then they were they were connected on site. And the fiber grate is kind of that light gray that's on the top of them that allows the aquarium staff to walk on it. You mentioned that these kind of long linear bands preserve buoyancy. The pontoons, trust me, they're under here. And then the PET, that sort of rigid, sort of sponge-like material, you can see it here, was pieced together and almost like a jigsaw puzzle. And so we tried to, as a cost-saving mechanism, rather than having it all custom, we tried to use consistent shapes so that it was easier to manufacture, and then it was put together like a puzzle on site. And that's that black stuff that kind of is in the large area where they in this photograph. What else did you talk about?
Well, just really with the PET. So besides that being different layers, so there's some that are only 3 layers high, because in reality, it's going to be sunk and it sit in about a 2-inch layer, a cover of water. And then there's the 5, and then there's 7 layer. The 7 layer is actually fully out of water. That's where all the shrubs are being placed, because they need to be proximate to water, but they don't need to be inundated. But what they did for the PET is they punched 2-inch holes, and we had set out a pattern system. So again, it was a lot of tedious documentation to show the grid work that was for that, to punch the holes, then 8-inch holes for the shrubs, and then all that had to be put together for the plan. And the people that were doing the PET fabrication for us were actually out of Minnesota. So you had a Minnesota team doing the PET fabrication and setup. We had a team in South Carolina putting the dock as well as the rafts together, and then shipping that up here. Another marina that was here locally, a coastal engineering team, they were the ones that were basically huddling all the pieces together and then bringing it over on barges to set it out and put it together. So it's a very kind of disparate teams pulled together to get this accomplished.
I always like to tell people that the PET schedule that we had was like it was like 2 or 3 sheets of 24 by 36 like shapes, and
it was 30 by 42.
Well, see, this is what Jason's here, but it was a lot. And I just like going through that was like it made every tough plant schedule look like nothing because it was like each of these shapes and where the holes are going to be drilled, and it was I don't think we'll ever do anything quite like that again.
Probably not. But, and so starting with some pictures here that we'll kind of talk to some of the things, but, the aeration system, that's Jack and Charmaine from earlier, actually working within the wetland. But, again, it's aerated. So there's, a large airline that's being brought over. It's going into 2 manifolds, and we call, we'll look at the plan, I can point out later, rooms. So we have a north, middle, and a south room. And so in the north and south rooms, there's 2 manifolds that basically take the air and then distribute it out there. There's 10 different zones. Each zone has about another 10 different feeders that go to it. And then there's 2 lines that go to every pontoon. So it was like really just a lot of spaghetti junction out there to be put down, to be held down. Like how do we, and things that we're thinking about, how do we keep all this stuff from floating up when it gets, set out there? And so that you don't see pipes and tubes everywhere. How do we hold the, reserve buoyancy? It's going to want to push back up. How do we hold that down so it doesn't pop through, which we asked them and fabricated in prototypes. We did it. The minute it finally got pushed down in the water, all of a sudden it was punching through the reserve buoyancy, the fabricated, kind of collars we're using. We had to then turn around and refigure that out. So it's a really unique project to be able to really, as we're working through it, we have a final solution. It's still a prototype. It's not exactly the final thing because they're always going to be manipulating, always going to be improving it, always going to be refining it.
So in this picture, Charmaine is walking on that fiber grate in the channel. So on that grate, on the gray, and then Jack is adjusting the manifolds, which control the air going through all of the pipes, and that we have that hidden in the benches in the rooms.
And so again, a little bit to the PET in the zones we talked about. There were different, the high marsh, the different salt grasses and low marshes And so again, there's a strata of the PET that was done to allow for that. And as you can see, kind of one little piece to the left, there was some that were punched, right? You can see the kind of the grid work that was there, and that was to allow for the plantings. So when we got to the plantings, and we have a slide that speaks to that real quickly, they had developed their own little mix of soil, if you will, which is really like a little bit of soil, a lot of sphagnum moss, and you shove that in the, into one of the little holes, and then you put your little plug of grass, and we went on the way. But they had figured that out. They had done prototyping internally to figure out, like, what do we need? How deep's this hole? How are we going to get the water? So again, that's how we had worked with them to develop the different layers and, you know, the sequencing of the different grasses and where they needed to be placed.
And it's interesting because that little bit of moss that went into the holes, it isn't like they don't need the soil to live now, but it allowed it to wick the water up to the roots, which were not long enough whenever the plugs were initially planted.
And then while we were doing all these big moves with this, some of the things that, again, were part of their criteria or how they wanted to have this installed was kind of on their side of things, which this is an example of that. They do with the pontoon system, with the whole wetland system and aeration, they knew they were going to get, you know, aquatic, you know, stuff to show, wildlife to show, and they're going to get, you know, the birds and the waterfowl. But the smaller things, how are they going to be able to maintain that? Because the system, the fiber grade is open. So if you want to have something to live there, it's going to fall through. They don't have any place to really habitat. And so what they did is they took a lot of just oyster shell. They went to different, you know, Jack was known, he'd go every day to a couple of the nearby seafood restaurants and take all of their scrap oyster shells and bring them out. And so that's what they did in the open channel, the fiber grade. They dumped oyster shell for spat, for small crustacean wildlife to flourish on its own and allow for like some of the smaller fish that would be within, you know, the grasses and stuff that need a little bit more of a kind of a solid surface, if you will. This gives it to them. And again, that's part of their own internal educational aspects to figure out what can do that kind of habitat growth for them. And so these are just some of the images that we, you know, that they shared with us of what they found in the area, not only just from this project, but from other endeavors that they've had, but particularly, yes, the turtles, a lot of mallards showed up. Basically, the first people to show up were the mallards. They kind of took over pretty quickly, and they're like, "This is pretty cool." But then we've also had, you know, some herons have shown up, and as you can see, the one picture in the middle, which was kind of a shock to everybody, is the river otter. That's an actual, you know, critter cam that they had put out there, and a river otter showed up during construction at the very end, and now has nested. They've actually have kind of claimed it for their own.
And they have wildlife. You can always know where it's nesting because, first of all, it's smashed down like the grass is. But they also have, like, you know, the wildlife cameras in that area.
So just kind of some practical, you know, information. Pretty much as far as the construction, you know, we had a really quick time track on this. We were kind of taking up the effort from 2017. Started up again, like, hey, let's go. So we ran. But yes, construction started late in 23. And we were kind of surprised because it was cold out, and we actually had some pretty good snows. And but they got the work done and started. And by March of 24, the system was kind of in place. And then basically in May of 24, we did the planting, and then September 24, we had the grand opening. So it was breakneck speed. It was a really, you know, fast turn and burn, but it was it was intense. It was great. It was just some of the construction photos here. One of the unique aspects of just working on this project, besides the fundamental technical nuance and design nuance of floating wetland, is how to get it built. And so we are in a slip. That should be no problem. But then all of a sudden, oh, by the way, there's a pedestrian bridge above your head with abutments and columns, and there's one that's on the edge of the project that you can't run into either. So before the construction gets started, they had to basically, the crane barge they brought in, usually the crane would be on the barge and that's it. They just put the crane straight down horizontal and they just slide you in. The crane was too big to make it. So they had to actually break the crane down.
I think the next photo, it might be in the next.
Is the next photo?
Yeah.
Yeah,
Close.
well, close. But basically, that whole crane there, they had to actually break it down. They couldn't have it connected to the actual cab. So they had to take that apart, put it on the barge with the cab, bring it in, then put it back together. Then they could start moving stuff. But they couldn't do that until low tide to slide up underneath there. And then as they were working in this, and you saw in the video, you could see how it was kind of moving around and stuff. It's like they were moving around like 6 feet at a time to position the barge, to do stuff, to put the piles in. The other thing that was unique, which we don't have any kind of way to show it, but the pier to the left in this image here, that's Pier 4. That is where the dolphin exhibit is, and where the dolphin's habitat is. They are very sensitive to noise, very sensitive to vibrations. So how do you pile drive 9 piles, basically 100 yards from where they are? So what ended up happening is every column or pier pile, was being put in. They put in what they call an air collar. So basically, they wrap kind of aerators around this, and it blows bubbles. So the shock waves from pounding hit the water that's being agitated, and it dissipates. And so that was a mechanism for, mitigating that. But then they also had aquarium staff on the barge the whole time, on walkie-talkies with the people that are inside. And the minute there was any kind of problem with the dolphins, they're like, "We're done. Come back in 24 hours." So we had that built into the project schedule, working with a habitat coordination team, that you need to build into your schedule stoppage days for dealing with the dolphin habitat. And luckily, we had only a few days that had that happen. But again, they've been known to have issues. And so it's not just your typical project of working on the land or working on, we're working fully over water and then trying to work with the, existing habitat of the aquarium.
I think our CM said to me once that it was like 3,500 text messages with the person who was in charge of the dolphins, who would just personally text him whenever things were happening. So that's commitment on all parts.
So the floating wetland, as you can see here real quickly, is just the raft systems are being brought in. They're being put off to the side and connected. The PET is going in. You can see some of the line work is going in for the aeration system out on there. The dock itself, the dock is floating. But it's just a static system of its own. It's tied to the 2 gangways that are connected to the promenade. And then there's the floating wetland that's active, if you will, is everything from the dock off to the top of the screen. All those back there. Correct. And then there's that side is technically the west side of the slip and of the system. The east side, which is basically on the backside of the dock, is a floating wetland as well, but it's basically tied to the dock. It's just a static system. There's what's called a slide rail system that allows to they're both independent if they need to float differently, but they stay together. But there is no aeration on that side.
And it's not installed yet in this photograph.
Correct. And again, part of this being a community, anchor, a civic anchor in a community spot. As a part of the effort, the aquarium did an outreach, asked for volunteers to do the planting because 30,000 plants don't happen fast. So they basically had over 300 volunteers, as it shows here, but they did that in 6 days. So they had kind of a matrix schedule of people coming in, different groups and what have you. And we were lucky as well. We had about a dozen folks from our team. And
it was like
VHG.
a ticket to get in Baltimore to plant this wetland.
And that may have been the same day because we later on that in this picture here, it was wet, it was cold, it was drizzly, but we still did it. But it was great. But yeah, it was a way to basically drum up and let people know this is happening, come up and visit and have a part to play in this. And again, there's only 4 species that were used, and that's what's listed here. And so while it doesn't seem like much when you're out there, the pictures don't do it justice now, because the pictures that we have at best of the plant growth that happened is it's 3 times as big as it's really done well. They've been surprised at how robust the plant life has grown in the system since they've installed it. And so generally speaking, that's of the 18,000 square feet of area. Let me do it now. Okay.
It's fine. You can do it twice.
As I mentioned, the otters. This is when we first saw them. So it was during construction, and you can see the deck is down and pushed it in. But this wasn't because we had a construction camera. This wasn't because we had a critter cam out there yet. This is actually the pedestrian bridge that connects Pier 4 that's up high. Look down. One of the this is after hours. This is one of the staff happened to be walking by and were like, "What is that?" And this is video footage from their phone. Footage with the bird otters playing.
Just the other. Yeah, that was the security guy, and he took that video and sent it to his granddaughter and didn't tell anybody else about it for like a week.
It was actually like a month, yeah, it was like a month. And randomly they were talking, and he's like, "Yeah, you know, when I send that video of the otters down there to my granddaughter," and they're like, "What?" And he's like, "Yeah, look." And they're like, "You got to be kidding me!" And so he had sat on that for about a month, not thinking much of it, and thought that, "Hey, you guys are doing this. You might think it's something that you're expecting," and like, "Oh my gosh, no!" And so that immediately got shared out pretty quickly on their Instagram and other kind of socials. It was pretty great. But as Amelle kind of spoke to earlier, their process to get to this point, and you know, it took a lot of steps to get there. Kind of the technical aspects is a $14 million project. You know, one of the unique things about it is you think of some of the things that, you know, there's the wetland project that's down in Chicago. There's other wetland projects you've seen that are in New York, and some of the things they're doing now down there. Each one's different. Each one functions in its own way. But as of right now, this is the only one that has an aeration system. That's what makes it different. But it also has intrinsically with it different requirements if it's ever to be reproduced elsewhere or be a part of something different elsewhere. And as kind of the big picture for this with the aquarium, you know, they are going after a patent on some of the, you know, pieces and parts of this, and, you know, where that might be applicable. So that's why I think it's really kind of unique that people are like, "Oh, you're going to be able to put this out everywhere." It's like, well, this was built for this. This is maintained, and it's got a certain, you know, process to it. So it's a discussion that needs to be had that if you want to do a floating wetland, what is your intent? How are you going to maintain it? What are some of the things that go into that? You know, this is the salt marsh. It's maintained. It's a very controlled system, if you will. It's not wave action. It's very minimal.
No wave attenuation.
Yeah, so
water.
It may be totally different if you decide to put one, you know, using the Chicago example. That's again the same internal. But if you wanted to do something on the coast, be it freshwater or saltwater, brackish water, whatever, that's a different system entirely. So how does this play against it versus something that might be needing to be considered as far as that?
Real quick before you change this, so this project was like, obviously, like all of our, like most of our projects that we all do, is an interdisciplinary project. Landscape architect was prime. I will say it's the first time that I ever worked with a marine engineer. And so that was interesting, like learned so much related to that. So we had, I think, you know, typical that you would expect, like civil, structural, marine. Then we also had Kovacs Whitney's for our mechanical and electrical. So, and which was different because it was about, you know, getting those air runs. And it was sort of a language that I don't think we as landscape architects spoke before. And I'm not sure we speak it that fluently now, but it was really a big learning curve because it was different consultants than we, you know, were used to working on whenever we were working on land. And so that was really exciting, challenging, but, you know, I think was necessary in order for the project to come together. And so we want to open it up for questions, but while we do that, this is just for in the background. This is just sort of raw footage from some video that we took there, and because it kind of helps you see it in a way and experience it in a way that is, you know, different than looking at photographs. It's just all real slow-mo. It'll go on.
So yeah, there's no volume or no audio, so feel free to.
Yeah.
Yes.
In that last photo with the video chat with the otters, your aeration system, what's the volume like around there?
I think what you heard was the inside of the building where the person was taken, but there is sound at the exhibit. You know, Jason mentioned that they have, you know, exhibit designers. So all of their exhibits internal have a sound associated with them, music associated with them. Their front entry plaza has music. So if you're walking around the harbor, you hear music at the National Aquarium, and each of the different rooms, those north, middle, and south room there have different music that plays. What is so interesting about this project is that they hired a team of 2 individuals to compose music specific for this project, and the melodies are in the first room it is like happy music, because the way that they've thought about these 3 rooms is sort of the first room is past, what was the harbor like before, and so all the interpretation is about what was here originally. The middle room is like what we're dealing with now, and in the middle room the music, I think it's the middle room, I always get these confused, the music adjusts to what is happening in the water. So like if it has, and I do not understand how this was done, but it has the.
I did hear Shaman mention, just to that point, there are about 5 sensors within this slip that they had previously, or added a couple more since the project, to measure various different things. But some of those measuring tools are tied into the system that for the middle room. And in this view right here, that's why I stopped it, is the room closest to us in this view, that's the north room. So we're looking, south. Then the middle is the smallest piece in the middle, and then the far back room, and the far back piece near the upper bridge, that's the south room. So each one has a different, kind of music scape as you go in there. The middle one is tied to that data. And so like there was they call it a pistachio tide. When we had that recent fish kill about in the past month or so, when that happened, the music there, actually I was joking with Charmaine about it. I was like, so did the music stop? What happened? It's like the melody that they had there then became very slow, and it became very kind of somber-ish, if you will. But then when it's working properly, the general kind of cadence or kind of the theme and feel of the different rooms is generally, kind of upbeat. So when the water's not quite right, when the data is different, in that middle room, you can tell. So it's kind of a unique aspect that we had never really thought about, but yet, again, they're exhibit designers. They brought a level of different kind of interpretation to the space through the music.
And you do definitely see the aeration happening, but you hear the music, and you also hear the sounds of Baltimore. Like this is by a major, roadway project.
And it's very muted. You hear like kind of like a bubbling and a frothiness, if you will. You hear more if you're on the dock because of the little channel jets they have there. That's where you hear more, but it's more just, again, you think about water being moved. It's not a bad sound. So it's not overbearing. It's nothing that would be out of the ordinary.
The only sense that they would sound with that hall.
Yeah. I just want to, for anyone who hasn't been to Baltimore, so I lived in Baltimore from 2008 to 2020. I can't overemphasize like how gross the harbor was, and so the fact that they're always there is just so mind-blowing. And it's just red blood really speaks to projects. It's not something I ever would have imagined seeing in harbor.
Well, we found out the otters were totally blowing our minds. So they've had otters. If you ever go to the aquarium's Instagram page, they put a reel up just the other day where the otter and what was new for them, raccoon, met face to face. And it's funny because I think they did really well with the audio. They used the Pink Panther theme because the raccoon is actually kind of parkouring, climbing across the fiber grate, not the fiber grate, the netting on the rail to get on off the gangway onto the dock. But they come face to face, and there's a little bit of a stare down. But they've had that. They've had fox come onto the dock. They've obviously had a lot of waterfowl. And other things pop out there, but those have been the main ones that were kind of like, I didn't know there's fox in the middle of downtown Baltimore, but they have been. So it's been unique that they've been able to bring this stuff back to the level they have. Yes.
Questions. The first one is kind of about the time back in the first slide, but I like it used to be natural, but it is kind of overdone. And the wetland very much moves with the harbor alongside going. So the idea of salt marsh, typically you have high But now you have a constant to keep that.
PET. Mhm.
So like all the plantings are entirely in that material except for the plant soils.
Correct.
And then where is the mechanicals of that aspect of it? Yeah. None. As you said, it's a very unique system.
Do you remember in the photographs you would see there were tubes that were kind of like all over in the construction. They look like spaghetti. They still exist. They're just covered with plants now. So you try to make them. When it was first installed, you could see the spaghetti of the aeration. It's served out of their building though. Like it's served out of their building and right. Thanks, Jason. So it's served out of here, and then you can see it come down, like it's up in that, it's underneath that bridge, it drops down there, and it runs the length of the bulkhead, and then it goes under the gangway to there and to there. These two benches have the manholes. And then it's just like spaghetti everywhere else, but just because it's covered.
System they installed in their building or?
Yes. So that was one of the unique aspects of kind of like learning the language that we're not familiar with, working with the MEP engineers for that. So they installed a new blower. And so kind of with the whole dolphin thing, there was a little nook that was back in there because where the blower was installed is basically where all the pumps and all the other systems for the tanks that are for the dolphins and that whole Pier 4 facility. So they had to put a new blower in there. So that was building a room that was sound and vibration attenuated. And so
an acoustical consultant, like one of the companies landscape architects ever had.
So working with acoustical consultant was also fun and interesting. And so yes, new blower for that. And then they were able to then come out of the building as she was kind of indicating, on the screen, and that's what's providing. It's a 6-inch line, and that brings it out there. They had to bring new power from the building as well and attach that out to the system. So there's those are the pieces and parts that are having that happen. And again, it's trying to make it as unobtrusive as possible visually. So we had to build some, kind of framework screens around the stuff that's coming down vertically. It's across the bulkhead in some rail struts that are kind of a little bit, more aesthetically designed as opposed to what they were trying to do off the shelf. And again, because the aquarium is very highly visual people. So there's a lot of things that went into this project where kind of like, we're going to do this. And like, oh, that looks horrible. It did, but it's a functional thing. So we had to kind of backwards, roll it back a little bit and then come up with something new for that. And so, yes, as you notice, when the construction photos are going on, like say the reserve buoyancy, you saw those big bars, the big black candy bar pieces. When that went in, that it is what it is on day one. Well, they found after the plantings, and again, we planted in May. By July, it's hot. It does get hot in the harbor. 100-degree days. We had a drought over the summer quite a few times. The grasses most proximate to the PET were starting to die off. We're starting to die back. It was because of the heat being just absorbed and radiating from there. So they had to do hand watering. What they ended up doing, as you can see in this photograph, or part of the video, is they actually wrapped all the reserve buoyancy in kind of like a coconut fiber mesh, kind of like a burlap, but it's coconut fiber. So over time, it's going to degrade. And it's ecologically safe to do so. But they tied that down so that way it blocks the visual, it blocks the heat. And then over time, it's going to get built over. And like now, when you go out there, unless you're really looking for it and it's there, you really can't see it. Plus, secondarily, a lot of some of the spaghetti did have to cross over the top side of that. And so this allowed them to kind of cover it and make it go away. I think really you asked about.
Yeah, I was like, what were the other?
So I was kind of trying to work backwards. Yeah, ask about the blower and the system there. The PET, yes, everything's planted in there, but because even though, like I said, it's like 96% air, the fibrous root system that they have, again, it's not like a taproot, it's fibrous. They can get through all the different little nooks and crannies and, areas of that. And again, that was something they had prototyped on their own internally to see how that works.
It's like PET is like an SOS sponge. If you've ever had one, it has all these holes in it, and it just kind of grows through the roots grow through there. So they only had that little bit of soil in the beginning to wick the roots down to the water. And now, I mean, I don't know if that soil, I assume, is washed out, but now it's just living. It's, you know, like hydroponics, kind of like it's just living on the water.
And then as far as, you know, yes, they have the system allowing it to do this and, you know, going up and down and kind of working with the wave systems. And what they have, you know, yes, the plantings that they have are in the water column where they need to be or not need to be because they need to be high. And as things are moving around, it's fine because they know that the stuff that needs to be wet and it gets wetter, no big deal. The stuff that is barely touching the water, it's fine to get inundated. So again, with that storm, you know, it comes through and blows onto it, that'll work out, or it's going to sit where it needs to be. So again, those are things that they had internally kind of vetted themselves. Like, are we going to be putting in stuff here that, like you kind of maybe alluding to, can it get wet or not, or is it going to get wet enough? It's kind of can live in both areas.
So, first of all, looking at the aerials, with different colors, different grass types.
Yeah.
Why did you go just 4?
Well, I wouldn't say it was us. The aquarium chose to do those because those are the ones that are most typical of the Chesapeake area. And there were ones that they knew that would be able to kind of live in an environment that's not technically a salt marsh. It allowed them to have something a little bit more robust growth pattern. And so that's what they ended up choosing.
They were successful in previous iterations of the project. Yeah.
And I expect that they should be able to.
No, like in fact, it's kind of funny that you asked that because the original prototype had a volunteer tree on it, and like they have had to adjust the buoyancy because the tree is like a greater weight than what was originally calculated for. And so we have said, like, from day one, you cannot change the plant material, or like no volunteers have to be taken out. So, but they may change them, but like I said no because I had that knee-jerk reaction to these volunteers coming in. I know that would be like a big problem for this project. I mean, they might change them because we only had 2 different types of shrubs that they ended up planting. And I think we started out with 4. The shrubs have really taken off in the prototype, and they're like 5 feet, maybe 6 feet high. The goal of the project is when you're down on ultimately when you're down on the learning dock itself, that you would be immersed and you would like see the vegetation. And we intentionally, versus seeing out farther into the city. Right now it's not there because it's only been installed for like a year and the shrubs haven't grown. But I bet you in 5 years it's going to be coming close to that point. So
I would say real quick, like this scene right here on the screen, relative to now, most of the grasses have grown so that they're basically, if you're in the water, like Jack is here, they're as high as the rail. They're that much taller. And then the shrubs are coming in now that you can actually see them, like they're actually forming their own mass. And you can see them visually more so. Like right now, you can't really tell that there's actually shrubs out there. And so those are coming in pretty quickly and moving a lot faster than I thought. And on the prototype, the groundsel tree is one that they planted here. They did over there. That one is easily close to 8 by 8 size. And so they're going to have to maintain these because there's, I think, 30 some odd of those out there.
Oh no, I always have this cheat sheet because I never get the numbers right. There are 126 shrubs out there. So groundsel bush and marsh elder are the ones that we ended up selecting from the long list. And then we have, smooth cordgrass and salt meadow cordgrass, like 2 spartinas that are the grasses that were used.
I'm curious about how the development project team said there were a lot of responsibilities that were reported before. So how did this whole team come together?
So the National Aquarium hired us to do the plan. And then we quickly kind of got into doing SDs for everything. And they asked us to work with teammates that they had existing relationships with. So it was almost like a prearranged marriage in some ways. And that's who we worked with. So the mechanical, they do all of the work in their building. And that's for, I don't know, like the past 10 or 20 years, they know these people really well.
They have their own aquarium badges. They're almost like employees.
Yeah.
They're there every day.
And that's also how we got the marine engineer. And those were the two that were suggested. But our marine engineer happened to also have structural and civil in-house. It just kind of made sense to work with them. Also on that list, they were not under contract with us, but the marine installer, I cannot think of the name, coastal engineering. But those were all, that was we sat at the table whenever they hired the contractors, and it was we had special long conversations with who's going to be our coastal, our marine installer, because that was such a critical part of it. So, yeah. We were talking about this on the way up here because for the people online, the question was, what is the maintenance and how does the wetland perform in the winter? We were talking this is one of the ways that in Baltimore, we don't get thick ice on our water. We might have ice on our water, I don't know, 1 week, and it's so thin that it actually, you can see it sort of floating whenever the waves move. So that was not a concern about ice coming up and meeting it. What you might expect, the marshes, the Spartina goes dormant, so it's brown now. They end up, their maintenance is kind of spring. I think it's I was talking to them, they were going to try to do it earlier this year. They did it typically, I think they did it March last year. This year they might move it up to February, that they're going to try to cut them back because it's gotten so thick. They have to cut them back, or else they get holes in the middle of it.
Yeah, and they've already for this fall, they already kind of topped off some of the shrubs and some of with the Spartina, some of the dead heads of the grass. So to break it down, so they're kind of maintaining it as they go for that. And as she was alluding to, Amelle was alluding to, they're testing it out. They got one growth season. They're going to see what they're going to do for the next one. But so far, and they do it as they need to as well. They'll go out there, and if things are starting to kind of fall over the waterway, they'll kind of trim up that edge. So it's not a fully, because a lot of times in a real soft marsh system, you let the grass go off the edge, things that live under there, or maybe not. That as it deteriorates, it provides some kind of nutrients and what have you. So they're kind of curating as they go, and it's every day. So there's always somebody out there that they come out there, they're taking the trash out, at times, and they're also going through and making sure that the grasses are having a viable and thriving system, and then also limit up some of the shrubs as they go to kind of keep it going. And
we don't get a lot of snow in Maryland. When we do, the whole world shuts down. It's pretty ridiculous. So I don't think that they shovel this. I think they just don't open this if there's snow on the dock. And usually if there would be snow on something that was, could get warm, it's probably going to be melted in a day or two. So.
And I don't know how big this
leave a section.
Just let's see what happens. That's the base.
I don't suspect that they would ever do that though, because just knowing them, they're tinkering in the science lab. If that makes sense.
That's a unique thing about this whole project too, as well, for the client base. So we were dealing with people that were hands-on, right? They're exhibit and habitat coordinators, and this is their jam. On the flip side, the PM for them and some of the other people that we would have to respond to and deal with, they're financial people, they're planner people for the overall, thing. And like I said, they're highly visual. There's a number of times things we were doing that just, there's one little nuanced thing they just didn't like visually. That thing is, you got this thing in the plan, and we're seeing your visuals and stuff, and it's going to be in somebody's eyesight, and we don't like it, fix it. And so I don't think that's where it's kind of like maybe more Disney-esque, right? They can't allow it to be a little more real because that's not a visual they could. That's yeah, exactly. So
decade of prototypes.
Yeah.
So they've been tinkering.
They've been manicuring them for yeah.
So the street, it's basically just the harbor, the aeration through it, and some of the shells of the grid.
Yes.
That's all it is.
Yes. And the slip, like at the bottom of the slip, it's like 50 feet of depth there. So this is, but it is floating at, it's submerged like maybe 6 inches.
yeah, the structural system is like 6 to 8 inches down, but then the lowest PET level where the grasses are sitting is only in 2 inches of water. Because like, again, the PET, because I wish
I know, I feel silly. We brought everything we did. We have a sample of PET that we didn't pack.
well, and also just the general contractor 3D printed the pontoons. And so you can kind of see the different like structural pieces that go together. It's like it would have been a good visual to kind of pass around and show on the screen. But yeah, because of that, it's at different levels and floating.
Yeah, how much of a great success that have you seen any sort of like funding pop up for projects like this going on places, whether it be Baltimore or other places? I mentioned before, be just a line, be on this that it may not work.
So the aquarium is trying to work with the Maryland Department of the Environment to have this qualify as a way for developers to be able to do, I don't think of this word, it's like, I lost it. Like if they can't do, all the stormwater management on their site, they can do it on another site. It starts with an R, the word I'm thinking about. It's like, but they're trying to work with Maryland Department of Engineer to see if people can like basically do a to buy into a fund that would allow this to happen. But so far it hasn't happened, but there are talks. Individual groups have reached out that are interested in it. Interestingly, they are not government groups. They are not. They're private. They're private groups, and in fact, like one industrial group that reached out. This particular project, though, did get a ton of funding. Like it got funding from a ton of different groups, but it was primarily all philanthropic, just private donations from like a big bank did a bunch of it. But this got money from Maryland Heritage Authority, Baltimore County, the state of Maryland, as well as Baltimore City. So again, my cheat sheet helped me out there a little bit. Yes.
So is there any ongoing monitoring and like a set of metrics for like not just like how well the regional but like the benefit for the water quality?
Yeah, so they measure, and they have been measuring the water quality since 2017, both at a control site that is like on the other side of the slip, as well as at the prototype. And if you saw in this video where Charmaine is sort of like dragging that thing through the water, like she's dragging kind of like a big hose through the water, she's doing surface water testing. This is done in partnership with the University of Maryland. I think it's IMET. I'm not sure what that stands for, but they have been sort of tracking it since the first prototype was installed. They also have been monitoring for habitat. And so that is both a combination of like citizen science. So it's like, people seeing and uploading what they see, but the National Aquarium staff goes out and they kind of know where to look for a lot of the animals now, and they will also add it to that site. And additionally, they have done a lot of sort of visitation, that whole aspect of, expanded public realm. They've done a lot of post-occupancy, like people assessment. And that all just kind of finished because this past August was 1 full year. So they're going to have 1 full year of the impact. And honestly, it has been released to us like within the past month, and I have not dug into all the information. I will say that for the prototype, interestingly, it the water quality did not have as great of a change as they had anticipated, but the overall water quality, the surface of the water where it has all the aeration had an incredible change, but the deeper water quality did not have the as great of an impact as they wanted, which is why they probably the animals are coming to the surface in those low oxygen level situations.
And it wasn't really touched on to that latter point of like the water quality of the prototype not doing as robust as they thought. It's more topical surface area. In the development and installation of this system, both sides of the slip had aeration applied to the slip sides. So again, along the edges, that has shown a benefit to a greater depth. But it would take a robust system to do this. It's a 50-foot, water column. But that's what they did because the system that they have for the prototype is it's right there. It's just in and of itself. But with this larger system, they went off the sides. It did twofold. It helped with the trash to kind of mitigate it from getting in around the wetland and the edges. But because now they're aerating and providing water oxygenation in a greater edge condition and expanded out there, that's helped as an overall. And then with the last pistachio type that they had, that's what they found is it's been a bubble. That they found that as things are dying off and they're they do have die off right there in their area because there's outside the wetland it doesn't have the aeration, but they're finding as visually that they're seeing it and inspecting it and also doing the measuring that water column of whatever feet deep below is where they'll find so much more fish showing up because that's the only place that they can go. But then they can look 10 feet away and they're seeing fish come up and actually gulping air out of this out of the water, trying to survive in the tide situation.
Apparently, one of the best times to go and see blue crabs there is during a low oxygen event in the water because they usually live pretty low, but they'll all come up to the top because that's where the oxygen is in those times.
How much of a concern of the materials you're adding to this first area would be great and contribute to microplastics or general fragmenting the water?
So that was a concern. And so it's kind of it's a catch-22 because using PET, it's plastic. But it's a durable thing and it allows for, it's a functional thing and a durable thing. So part of the way in which to kind of mitigate against that is all of the PET was coated in what they call like an armor material or coating. It allows for greater UV stability and protection. It also gives a little bit more of a hardened aspect to it. So it can take a little bit more of a beating, being inundated. And it's one of those things that because it was applied in the field, but then applied in the shop, it was kind of done. But then we had to make some field, modifications. We had, applications that were done on site as well. And again, it was to guard against that because it is a concern now that we know how much microplastics has permeated everything. But again, in order for the system to work, that was like the only viable, piece and part that we could use for that. But it's again, that goes back to them learning, tinkering, and doing. It goes in the column of useful knowledge now, and there's an alternative that comes about, and then they can switch that out.
And interestingly enough, sort of the increase in understanding of microplastics, in water and in our world, over the course of this project, the study of this project has we were kind of beyond the point of no return whenever it was identified, if that makes sense, whenever it was identified as how critically important it is.
Looking at the system, it seems like I didn't notice anything that was particular the saltwater setting. It seems like in general, it could work one way or the other because it's not really working with the tide. It's not getting tidal flux because it's going up and down with the tide rather than staying stable on the other. So it seems like the concepts could be transferred to freshwater.
I will tell you that, yeah,
as you said,
without the waves. Yeah, I will tell you that like Charmaine, she's like, wouldn't, because we were saying, what would your dream be if we could do the next project in the plan? And she's like, I think I'd want to do, and she didn't even go to what they do on site. She's like, I think that I want to do one of these in the freshwater. Yeah, so.
One more. Let's see.
I'm curious if you have similar to your project. What's the carbon footprint of the project? Obviously, it has a lot of positive outcomes from an ecological standpoint. For a life, a lot of biodiversity, but the inputs were obviously quite striking.
We don't, but that's like, that would be a really good thing for us to calculate with our sustainability.
Yeah, we have a sustainability team that, of course, for a building, it's embodied carbon and a bunch of other things that can be part of that process. And so that's something we have not really studied. And of course, with the aquarium, I don't think that's kind of, it may be within, partially the purview, but it doesn't really capture them. But I think that's a really good point, that it'd be interesting to see like, what was the carbon footprint and aspects of the construction and other materials, and then extrapolate that out to now, what is the carbon offset with now we introduce a new system of plant material that can help, right? So there's two different ways to look at the carbon footprint. And I think that'd probably be a really good science experiment and study for a team to do.
And I know that we were disappointed because like the makers of the PET for the prototype, they were based in South Carolina. And but they went out of business in the time period between like they did the prototype and whenever we did this. And so there was like a startup in South Carolina, but the aquarium ended up for financial reasons and also because they could guarantee the product going with the one in the Midwest. Minnesota, right? It was in Minnesota. But we were disappointed because decisions that we made about having the pontoons made off-site in South Carolina made no sense whenever then they had to truck the PET from Minnesota to the site. It didn't make any sense. And it was just the reality of there are a handful of people that make this product. And cost and confirmation that they could follow through was a big part of doing that. On our time frame was a big part of how we made that decision. But we were disappointed about that.
So thank you very much.
Thank you.
Thank you back. Questions?
All right.
Thank you.
Thanks a lot.
Yeah. Thanks.